I'm Adam Poltorak.
I'm Kathleen Flowers.
And I'm Kathleen Stone.
And we're the IRAs. Okay, so this is an overview of our GUI project. We have tasks 1 through 5 given on the left and the remaining tasks on the right when any plot will come to axis. For task 1 through 5, this is a simple flowchart of how it will work. So you're initially asked for an index or price. From there, you will be given the available selections for either the index or price according to what you selected. From there, you have then the option to plot 4 different graphs: price per month, price for year range, quarter bar chart, or a year bar chart, with inputs for a given year range, and then you will plot it. So when you first open the program, this is the initial screen that will pop up. On the left side, you'll have an option to choose between commodity price indices or individual commodity prices. And from there, you will have the selection based off your first one. So for individual commodity prices, you then have these options for that. From there, you'll be able to select a graph. You will have 4 graph options. The first graph selects every month input and graphs the trend of that month for every year available for that data. So from there, when you select that, this pop-up menu will now display. You can select any month from January to December, and it will plot. If you go to the second graph, then you will be asked to input the range of years that you would like to display. So for example, if you do 2000 to 2005, it will plot every month value it has in the indices of the data range that was given. We also can see that when you select the same data range for the same year, it will then plot specifically for that month and display each month that it does plot for. We see in the bottom left-hand corner that it does give the range for every year and month available for that item. So, for example, this item starts with 1992, and it does change according to what you do select. An additional feature we have added to all of our graphs is to display error message when you enter a year that's out of range. So for the selected all commodity price index, we see that it starts with 1992. So for example, if I put in 1990 to 1995, it will display an error message here: entry was not valid. It still will plot, but it will not have any data points to plot for. It will also, if you go out of range, so for this case it goes to 2015. If you do 2014 to 2016, it will display a message where it exceeds the valid range of years.
A third graph that we can select by first selecting a specific commodity or an index is the bar chart for the quarter data. By entering in a specified date range, we can plot all the quarters over the date range for the specific commodity or indice. As you can see, we have the average plotted in addition to the standard bar chart. In addition, if for special conditions where 2015 is the ending date, as we are only provided 2 months for 2015, the quarter will only be plotted as those 2 months for that year. The fourth chart that we can plot is the bar chart for a desired year range with bar charts over specific years. As we enter in the date range, we are given a box plot for every year in the range, again with the average and specific box plots. Again, if we have an end date of 2015, as we are only provided 2 data points, it plots just those 2 data points as those are the only ones provided. For all 4 graphs that we provided to plot, the title will change depending on what the graph type is, what the name of the object or indice selected is, and the specific year with month range. In addition, the units for every specific commodity and indice will change, and the labeling for the x-axis will change depending on if it is quarters that are being plotted or years, etc. As shown in the plots for graphs 3 and 4, which feature bar charts using the function boxplot, this is a standard box plot that we would get for a column array. To edit the graphs that we plotted, I had to make sure that the median line was not visible to the user, as this was not one of the required values. Instead, I did an overlay of the average of the value, and it ended up within the correct column and box plot. In addition, I had to extend the whiskers to a length of infinity in order for the outliers to become the ends of the whiskers to show the min and the maximum.
For the next portion of our GUI function, it will be to carry out prediction based on collective price trends over the year range 1990 to 2015. Here's a list of 4 commodities that you can select. When you choose a commodity, like cotton for example, it will output the predicted price for the day, and along with that, the current price Wall Street Journal of the day you're running the program. The value is then compared. For the next portion, we can predict a future year for a commodity price. We will choose 2017, for example, in the month of March. It will graph the predicted values and then the actual values, and also give you a predicted price for that month and year.
Task 11, where we obtain the current price from the Wall Street Journal of the 5 different commodities, I use URL read to access the current Wall Street Journal site content for each day. We then use regex to identify the index of each commodity on the site content, and then find the distance of the commodity name to the specific value of price. We then obtain the value and print on the GUI text box here. In addition, we include the units from the Wall Street Journal, and then take our predicted value from before and convert it into the same units.
The way we find EMA is we have 2 points, one representing 1 month of 1 year and another month of another year. We take the first point and we take the one before it and we take the difference between those 2 points. And then after that, we multiply by a constant of k, which depends on the amount of data points in the commodity. And after we multiply by k, we add it from the initial, which is this point. And then from that, we get either a more flattened slope or a more heightened slope. So we get something like that. And so we have, then we graph the best fit, and with that, we can calculate the predicted price at any point in time. In order to find the best coefficient, whether it be odd or even, we need to look at the end behaviors of the graph. So we look at original EMA, take 2 points, one here, one there, and that will tell us whether it's going down or it's going up, and we do that for this end. And if it's both going up, that would be an even graph. If one's going down, one's going up, that would be an odd graph. And that's decided by negative slope or positive slope.